Hello, today I'm going to go over exponential problems and switching in between logarithmic form and exponential form. So I'm going to start off with 3 to the 2x minus 1 equals 27 to the 4x minus 5. When solving exponentials, if you're able to get the same base, then you can drop the bases and you can just solve for the exponents. So that's what I'm going to try and do here. So since 3 is already a prime number, I'm going to use 3 as the base, if possible. So 3 to the 1 power is 3. 3 to the 2 power is 3 times 3, which is 9, and 3 to the 3rd power is 3 times 3 times 3, which is 27. Let me squeeze that in right there. So here, since 27 can be represented as 3 to the 3rd power, I can go ahead and copy this left side down and substitute 3 to the 3rd power for 27. And if you notice here, our bases are the same, so we can drop our bases and solve for the exponents. So now I have 2x minus 1 equals, but notice here you have two terms up here in the exponent area outside of the parentheses. So what's going to happen is this exponent of 3 is going to have to distribute across both these terms. And so here I'm just going to copy this left side down, and now I'm going to have to distribute that 3 across. So 3 times 4x is 12x, 3 times negative 5 is negative 15. And now I can start by isolating x by moving all your x terms to the left side. Here we only have one term to move to the left side. And 2 minus 12x is a negative 10x. We're left with negative 1 equals negative 15. And here I can finish at isolating x by adding that 1 over. I'll get a negative 14. And I can go ahead and divide off negative 10 from x. Here the negatives cancel, the 10s cancel, and also on the right side our negatives cancel off. And we have x equals 14 over 10. But if you notice, both numbers are even numbers. So any even number can be divided by at least a factor of 2. So that's what I'm going to do here to simplify our fraction. And if you do that, x will equal 7 over 5. So that is your answer. Okay. I'll go ahead and fix that. Our next problem will be 1 over 49 to the 5th power minus 2x equals 330 43 to the 3x. Here, this problem seems a little more complicated, but we're going to try and attempt to get the same base with this problem as well. So here, if you have a number 1 over 49, you can use the rule x to the negative 1 power is the same as 1 over x. So here, since this number is under 1, we can go ahead and flip it by showing it as 49 to the negative 1 power. And now what we want to do is to go ahead and try and represent these two numbers with the same base. So I'm going to try and represent them as a multiple of some prime number. I'm going to use 7, since 7 squared is 49. So 7 to the first power is 7. 7 to the second power, 7 times 7, which is 49. And 7 cubed is 7 times 7 times 7, which is 343. So here, since 7 squared is 49, we can replace 49 with 7 squared, so that'll be 7. And here, when you sub in that power, you'll have 2 times negative 1, which is negative 2 up top. And I could have actually shown that separately if you like. I could show that as 2 times negative 1 while keeping 5 minus 2x on the outside. And here, since 7 cubed is 343, we can replace that with 7 cubed. Okay, so now since 2 times negative 1 is negative 2, we can show that as being just a negative 2. And here, since both these numbers have the same base, I'll go ahead and drop them and just solve for their exponents like we did with the last problem. Ooh, that'll be a 2x. And again, since this is on the outside of the parentheses and this number is on the inside, we're having to distribute that negative 2 across. We have two separate terms here to distribute it across. And here we have 3 times 3x. In distributing that negative 2, we'll have negative 10. And here we have a negative times a negative, which is a positive. 2 times 2 is 4, and that's a 4x because of this. And 3 times 3x is a 9x. So now we can go ahead and isolate your x term. Here I'll actually move your x term to the right side. We'll have negative 10 equals 9x minus 4x, which is 5x. And to finish solving for x, we'll divide by 5. And here 10 divided by 5 is 2. They have opposite signs, so that's negative, and that equals x. So here x equals a negative 2. Okay, so with our next problem, I am going to have 11 to the x plus 4 power equals 97. So here, notice how 11 is a prime number. So here 11 to the first power is 11, but 11 squared is 11 times 11, which equals 121. So here we cannot represent 97 as a multiple of 11, so we are going to have to use a different method here. So here, what I'm going to do is we're going to use a rule of our logarithms. So you can do this either with a regular logarithm or a natural logarithm. I'm going to use a natural logarithm because that's what you typically see with these kinds of problems. It doesn't matter which one you use. I'm just using this because you're more likely to see it this way in a textbook. So here, if you have ln x with some power over the argument, you can move it in front of that natural log. So I can take ln of both sides and notice here that ln of 97 is still just a number like it was here, so this is just a constant. You can evaluate that in your calculator, so it is just a constant. We're going to treat it like a constant. But notice here I can move the power down, so I can take this, move it down out front, and I can have x plus 4 of ln of 11. So now I brought the x down so I can solve for x, but right now it has an ln of 11 to distribute across that parentheses. I don't feel like doing that, so something that I'm going to do is, since this is factored out front, I can divide ln of 11 on both sides, so I don't have a bunch of natural logs all across my equation. So these cancel out, and all I have left is x plus 4 on the left side. And now I have ln of 97 over ln of 11. And the last thing to do to isolate x is to subtract that 4 over. So here x equals ln 97 over ln of 11 minus 4. And if you have your calculator, you can take that, you can evaluate that to 4 decimal places, because that's what you typically do with your logarithms unless you're working on a problem and it states otherwise. So I'm going to do natural log of 97 divided by natural log of 11 minus 4. Okay, did I have... Let me make sure I had that typed in correctly. Minus 4. There we go. So here, that's approximately negative 2.092, and here I have a 19, so rounding it, to the nearest 10,000th place would be a 2. Okay, so now what I'm going to do is I'm going to show you how to switch in between exponential and logarithmic form. So here I have a problem. 36 to the 2/3 power equals 216. So with this, I am going to use exponential form. So if you have something in this form, you can change it to a logarithm in this form. So here, the idea with your logarithms is that it creates exponents. So like with earthquakes, your logarithms are what they use to measure earthquakes. You use logarithms to measure pH, so it's really important. So here, since y is the exponent, since your logarithms create exponents, notice how in exponential form it's attached to your base here. And in exponential form, the base of your logarithm is the base of your exponential. So that's how I like to think about it. The base of my exponential is the base of my logarithm, and since my logarithm creates exponents, it equals y. And here, your exponential equals some number, and that number is the argument of your logarithm. So that's how I like to think about it. Some people like to think about this in a counterclockwise idea. So if you're switching from logarithm to exponential form, you use a counterclockwise method. Start at your base, then y is attached to your base, and it equals your argument. But if you're constantly switching back in between exponential and logarithm form, it just helps to have a better understanding of what to do. So here I am going to change this into logarithm form. So since this is the base of my exponential, 36, now this is the base of my logarithm. And since my logarithm creates exponents, well, here 2/3 is the exponent of my exponential function here. So my logarithm creates 2/3. And its argument is whatever this exponential equals. So here, that's 216. And so now that we have that down, I'm going to change a logarithm into exponential form now. Oh wait, oops, I copied this down wrong. So here that was 3/2 here. So when I changed this into logarithm form, that would have been 3/2 here. So just ignore that. So for this logarithm, I have a base of 125, so the base of my logarithm is now the base of my exponent, of my exponential function. And since my logarithm creates exponents, this is now the exponent attached to my base. And your exponential creates the argument of your logarithm. And if you like the counterclockwise version, there you go. So that's all for today. I have links down below to my Patreon as well and my Twitter, so you can go ahead and support me there. I will be posting different videos on my Patreon. The only video that's the same on there is the intro to my channel. You won't find any videos in common on this channel and my Patreon, so you're going to have to subscribe to me there and support me there if you want to see that. But otherwise, have a good day, and I'll see y'all later.